So this can also be helpful for looking at functions where x approaches infinity for our limit. Now, I'll just be honest with you. I would not personally do this with L'Hopital's rule. I would use this with the horizontal asymptotes and thinking about which function grows faster. But so we're going to do this problem twice, but I will model this using L'Hopital's rule. Plugging in an infinity, I can tell I'm going to get an infinity over infinity, which is an indeterminate form. Okay, so I can tell that the limit of the numerator is going to be infinity, and that the limit of the, I like arrows with limits, and that the limit of the denominator is also infinity. So this is an indeterminate form. Wow, that's fun. And so I can use L'Hopital's rule. So when you use L'Hopital's rule, I'm going to write the limit notation again, and I'm going to take the derivative in terms of x of the numerator separately from the denominator. Don't forget the chain rule. And then if I evaluate this, I could tell again that I'm going to get another infinity over infinity. Now, College Board, I've not really seen them use L'Hopital's rule with infinities. So they usually use it with zeros, and then you usually only have to use it once. So I'm not going to be too picky if you write this infinity over infinity here instead of listing them separately. But just don't put an equal sign, okay? I will be very disappointed if I see an equal sign there. Since this is another indeterminate answer, I'm going to go ahead and do L'Hopital's rule again. I'd get 6x over 4 times e to the 2x. So when I plug in infinity, I get an infinity on the numerator and denominator again, which is still an indeterminate form. But now I get 6 over 8 e to the 2x. Well, 6 is not going to approach infinity. It's a constant. Some constant divided by a very large number will approach 0. And so L'Hopital's rule could eventually get me to this answer of 0. So with limits to infinity, you could use L'Hopital's rule. I wouldn't. An alternative way of solving this is to think about horizontal asymptotes, because limits to infinity is really like a horizontal asymptote. And so you could think about the rate of growth of which grows faster. We have a polynomial function divided by an exponential function. And so we have something that's relatively slow growing over something that's quite fast. So we have a small number divided by a very, very large number. This is going to approach 0. I find that to be easier. I've never actually seen College Board put a L'Hopital rules problem that has a limit to infinity on a free response. So I don't think you need to worry as much about the notation on that, and I probably wouldn't use it that way anyway. I'd probably use this. Now, something important is that L'Hopital's rule does have a condition. You have to check first to see if the limit's indeterminate. If the limit's not indeterminate and you try to use L'Hopital's rule, yeah, it unfortunately doesn't work. It only works with those indeterminate forms. So here's an example. Why don't you pause the video and try this one with substitution and then restart it. So if I use substitution here, I would get 5 minus e to the power of 0 over 3 times 2, which is 6. So I'd get 5 minus 1 over 6, or 4 over 6, which is 2/3. That's not indeterminate. So substitution as my first line of attack here worked perfectly. Now, just to verify for you that L'Hopital's won't work here, if I try to use L'Hopital's rule in this problem, it's not going to work. I'm not going to get the right answer here. So what I'm going to show you right now is just evidence of why you couldn't use it for a limit that didn't have an indeterminate form. If I did try to use L'Hopital's rule with this problem, I would use my limit notation. I would take a derivative first. Derivative of a constant, zeroes out. I do want to consider the chain rule, but here the derivative of this exponent is just 1. So it doesn't do anything. If I then evaluate this at 2, I get negative e to the 0 over 3, which is negative 1/3, which is false. We know it's false because we know that it was actually supposed to equal 2/3. So don't try to use L'Hopital's rule for a problem that is not indeterminate. And that is the end of our notes for 4.7.